So this video is a review of graphing sine and cosine functions. We're going to put everything together now. So we have four letters, A, B, H, and K. Our Y and our X are our coordinates. And so these four letters will modify our sine function and our cosine function. Let's start with A, which is the amplitude. So if you notice right now, we go up 1 and then down 1 with a period of 2 pi, right? So it's going to go up to 1, back down to 1. And there's our 4 points, just like our quadrant. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if I change my A, instead of going to 1, I now go to a height of 2. So you can see that number in front of the sine tells us how high we're going to go. So now I'm at a height of 4. See? 4 and 4. So whatever number's in front, it tells us how high we're going to go. And if I made it negative, now you can see we go down 4. So from 0, we'll go to negative 4 and then up to positive 4. So there's positive and there's negative. You can see it just reflects it about the x-axis. So negatives mean we go down. Positives mean we go up that number of units. So the other number that is outside of our function is our k. And so right now we're at 3. So you notice with k, what k does is it moves our graph up and down that number of units. Let me lock this in at 1. So right now I have moved it up a k of 1, so my whole graph you can see went up 1. It actually now oscillates along this y equals 1 line. You can see that every single point has a y coordinate of 1. So that's just telling you what our y coordinate is right along our axes here. So whatever that k is, that is our new axis. Right there, 3. So you can actually put these numbers together. Let me put this back to 2. So we have an increase of 2. Everything's gone up 2. You can see that, right? But what we're looking at now is here. So this is 2, which means our height now is 3 up from 2. So it's 5. So you can see you can just add those two together and it tells you how high you're going to go. And then if you subtract them, it tells you how low you're going to go. So 2 plus 3 would be 5 and 2 minus 3 would be negative 1. So adding those two numbers tells us our height and our lowest point. It tells us our range. We're going to go from negative 1 to 5. So that's what the outer two numbers do. The k moves it up and down, and the a stretches it. It gives us our amplitude of our graph. Okay, let's go back to 1 and to 0 with this, and there's our basic sine graph again. Now let's look at the inside stuff. And so B is our period. It's a very, very important thing. So watch what happens when I make my B a 2. It just got shorter. Because what happened is that 2 means it's going to occur twice as fast. We are going to double every single angle. So if you plug in 30, it now becomes 60. You plug in 60, it becomes 120. Things occur a lot quicker. In fact, they occur twice as fast. So our period will happen 2 times within the normal 2 pi period. And so that's why we always do 2 pi divided by that number. So if it's a 2, 2 pi divided by 2 is pi. And if it's a 3, that's literally 2 pi over 3 right there. And if it's a 4, well, 2 pi over 4 is pi over 2 right there, see? And so if I went to 5, it's going to happen 5 times as fast. And if we do a fraction, like a half, so I put a half in there now, you can see that it happened twice as slow, half as slow. It's very, very slow. So instead of being at 2 pi, it now does it in 4 pi, because if you take a fraction and flip it, right, then that's how you're going to get your number. So this is actually 4 pi. It'd be 2 pi divided by a half, which is 4 pi. So that number in there, so if I had done a fourth, write that. See, 1/4 now means it's going to take 8 pi to get our full period, because 4 times 2 would be 8. So any fraction you get, you're flipping it and multiplying it. And any whole number, like 2, it now happens twice as fast. So you can see what happens, that as the number gets bigger, the period gets shorter. And negative just means other direction. See, flips it across the y-axis. So it's the same basic idea. Okay, so that is our period. Now we only have one letter left. So again, the A and the K affect the amplitude and our heights, and our B affects the period. So what h of x are, and it shifts it left and right. So right now you can see it's at 3 pi over 2. That is 3 pi over 2. So whatever number you have for h, opposite sign of course, that's why we have minus. So this is x minus 4.7. You'd be at 3.2. Look, we'll take it back to pi because you know that one. That's 3.14, and you can see we're now starting at pi. So we're normally at 0, so it's been shifted pi units, because if you were to plug in pi take away pi would be 0, and so it takes us right back to 0. Sine of 0 is 0. So whatever number you have here, that's what's going to shift it. So if we do that, we're now at pi. We know it's been shifted pi units. Our period here is 1, and so if I make it a 2, it would now be 2 pi over 2, which is pi. So you can see we're starting at pi, and we're pi units away. Right there, that's our period. And then they're going to add a k, and so we moved it up 1. And so now it's been shifted up 1. And we can have an amplitude of 3. So we're going to put all of this together in that situation. So that right there, the pi is where we start. And then 2 pi over 2 would be pi. So we're going to go pi units away. So pi plus pi is now 2 pi. We've shifted it up 1, so everything is going to oscillate around 1, and you can see the 1s there. And then we have a 3. So we're going to go 1 plus 3. We're going to go up to 4. And then 1 minus 3, we're going to go down to -2. So that's how those 4 numbers work. We're going to start with just the x's first and find out where do we start. Find out how far away we go for one period. What is everything oscillating around? And then how high do we go up and how low do we go up from that 1? All right, so let's try one. So we have our graph here, and I've gotten everything written down up here for you. So our graph says it's 1 plus 3 sine 2, and then parentheses x minus pi over 2. So we know our amplitude here is 3. So we can say that that's 3. And we know it's going to have a shift of pi over 2. So that's our horizontal shift, pi over 2. And we know we're going to have a vertical shift of 1. So we're going to have y equals 1 is what we're going to oscillate around. So we already know that this is y equals 1. We don't have to think of it as just plain old 0. You could say that that's y equals 1. Our whole graph has been shifted up 1. Our period now is affected by that too. It's the only one left. So this guy right here is our period. And it's 2 pi divided by that number, that 2. So whatever we get for that number, simplified, so it's period. So I know our period's going to be pi. So we're going to start at pi over 2 and then go pi units away, which means our interval would be from pi over 2 to pi over 2 plus pi units away. So this would be pi over 2 to 3 pi over 2. So we know that's how our graph is going to look. But what we want to do is have nice clean marks on here. And so you already knew that for each graph we get those four marks. 1, 2, 3, 4. And so we're going to put those 4 marks in. And what they are is always related to that period. So if I shift this back to 0, and we'll even take this back down, right here you can see it's pi units. And so if you think about it, this is just a fraction. It's a fourth. So we're going to take and cut that fraction into 4. So you see pi, that would then be pi over 4. It's whatever the period is times a fourth. So this is 1/4 pi, which would be pi over 4. So you just make some marks on here. 1, 2, 3, 4, 5. We go the other way as well. 1, 2, 3, 4, 5. And we know that that's pi over 4. And then you just have to count. So it would be 2 pi over 4, which is pi over 2. 3 pi over 4, and then 4 pi over 4, which is pi, and then 5 pi over 4. But once you have taken your period, cut it into 4 parts, you now know where your little tick marks would be. And then this side is just negative pi over 4. And so that would be negative pi over 2, negative 3 pi over 4, negative 4 pi over 4, that's negative pi, negative 5 pi over 4, and then it'd be 6 pi, which is 3 pi over 2, and so on. All right, and then now we need a starting point. So we already know it's at y equals 1. And then our marks are going to start at pi over 2. So let's put that one in red. You go to pi over 2 and you put your first dot. because we know now that if I were to plug in pi over 2, this would be 0 for sine times 3 plus 1. It moves the whole thing up 1. So from here, we're now going to go up and then back to the middle and then down and back to the middle. And if that amplitude, right, that 3, it's always positive for amplitude, but if there was a minus in front, then we would have gone down 3, back to 0, up 3, and so on. So what we need to do now is use that amplitude. So we're going to go up 3, 1, 2, and 3. And so we started at 1. So 1 plus 3 is, you guessed it, 4. And then we're going to go down 3. So 1, 2, 3. And so down 3 would be negative 2. So now we can start marking our graph. So from there, we already have our 4 marks. You're going to go 1, 2, 3, and we need one more. And we already knew we did it because it was 3 pi over 2. That is what our interval for one period is going to be, pi over 2 to 3 pi over 2. So it's always up, middle, bottom, middle, and there is our graph. So this nice graph, up, middle, bottom, middle, and then we'll check in desmos by moving our stuff. So it's 1, 3, 2, pi over 2. So our amplitude is 3. We're going to move it up 1. Our period, we are affected by 2, so it's pi. And then we need to shift this pi over 2. So that's pi over 4, pi over 2. So this is our graph. We should be starting at pi over 2, 1. And then we're going to go up to 4. See, perfect. Back down to 1. Back down to negative 2. It checks perfect. And then there's our 3 pi over 2. That is our graph. You can see it right there. And there we go. You can also check this in your graphing calculator by entering this as your period. Okay, now we said we're also going to be doing cosine. So I've given you the exact same function, but with cosine instead. So everything transfers the same. The only difference now is that it's a cosine graph. So we already know it's y equals 1. Our period's going to be the same. So we go 1, 2, 3, 4. So you're basically just making the exact same graph, whether it is sine or cosine. Same thing. So we're just going to copy everything that we have up there except for the graph. Negative pi over 4, we don't have to go that way now. And then we're going to go up 3 because we have that same 3 amplitude, down 3 because we have that same, and that would be 4 and negative 2. And then we know we're now starting. And so I'm not going to put a dot there, I'm just going to put a red line, and we're going to go back and look at. So this was our sine graph, and here's our cosine graph. So if you look at them both together, you can see that that little green part here with the little 4 marks is exactly the same as what we have here. The only difference here is that where we start. This one starts at the 1, and then we go up to 4 and then down to 2, negative 2. This one, however, starts at the 4 and then goes down to negative 2. It's going to go 4, 0, negative 2, 0, and 4. So instead of starting on the 0, we start here. And then it's that same pattern, middle, middle, bottom, middle, top. And we get that same. And so that would be our cosine graph, just like that. And it would just continue the same exact thing. So if you want to keep going, it would be just like that, top, middle, bottom, middle, all the way across. Same with the sine function. It would just keep continuing forever and ever and ever, just like that. So if you wanted to, you can continue your cosine graph. But once you have one period, it's just a basic trace from there on out. So that's why we want one period on each of these. So there you have it. That's your graph. So again, sine starts at 0, cosine starts at the top. Now if that had been a negative in front, so a negative 3, then instead of starting at the 4, we would start at the negative 2, the bottom. Thank you.